Happy to see the projects moving forward. Today, I wanted to talk about an issue that I sort of mixed feelings about spending the full lecture on it. It's probably one of the most important issues, arguably the single most important issue within a project. Effective understanding of requirements. Certainly one of the top couple. If you look at surveys of industry projects that have encountered problems, it's the number one problem that appears at the top of that list is requirements issues. Okay. I had some mixed feelings about sending the entire lecture on it because a lot of it is it's stuff that you need some experience, and you can talk about it in abstract ways, but really, when it really comes down to it, there's a lot of on-the-ground sort of experience with stakeholders that's needed to appreciate some of the points. And the points here relate to the fact, well, around this issue of a requirement. And basically, a requirement is criteria that has to be satisfied by a successful project. And much of the success of our projects hinges on whether or not we understand these requirements well and can act on them appropriately. But if we don't understand them well, if you don't know where you're trying to get to, it's hard to get there. Often there's, in terms of requirements, there's some impact on the user. There's some problem that's been solved, some gap between what is currently and what they want that's been narrowed or addressed. Jerry Weinberg, in a wonderful series of books that integrates sort of systems thinking, some things some of you might have seen in 394 with software development project issues. He defines requirements gathering or elicitation as an attempt to discover what product is desired by people. And you'll notice the bolding of it, which is his. It's an attempt. It's actually not easy. We try to do it. You have to discover it. It's not handed to you. Gathering makes it sound a little bit like it's a very straightforward activity of picking up, understanding. It's actually requires quite a bit of active proactive sort of probing. Trying to find a product that's sought by people, and it's oddly hard. I mean, it's the difficulty it is more than you would think at first, and it's extremely important. And in your projects, you're going to need to elicit requirements. A particularly notable feature of this is for the two teams that will not be interfacing directly with technologists. There's going to be a special challenge because you are dealing with a domain knowledge gap and a knowledge gap on both sides that is really significant. So if you're dealing with a surgeon, they're going to have all sorts of knowledge about surgery and the surgical context and operating theaters, etc., that it's going to be second nature to them. And understanding that could be important for delivering value. Similarly for the long-term care facility safety app. There's just going to be a lot. When Donna Goodrich, as the stakeholder, says something about patient safety app, she has decades of experience knowing what those terms mean in concrete ways, people's attitudes towards them, the different types of safety issues, and you don't have that knowledge. And you have tremendous amounts of knowledge of the solution space and what solutions could look like and what the relevant technology constraints are, etc. And she doesn't know those things, and there's a gap. Even when you're dealing with technologists, like with Casper, what they're doing is in the area of properties, and maybe some of you have bought houses. Maybe some of you are knowledgeable about that. Okay, not many, maybe. But I mean, property searches, real estate has its own domain knowledge, its own set of definitions and jargon. And even there, when you're dealing with a technologist, there's going to be times where you're going to need a lot of clarifications. So the goal here is to try to motivate a respect for requirements. I don't delude myself into thinking I'm going to pour into your heads all the knowledge you need to go and elicit requirements with great safety. That's not possible. But at least you should have respect for the fact this is not easy and you got to be careful about it. And I'm going to provide some tips for eliciting requirements more reliably, given these gaps, for lessening the ambiguity of things, spotting inconsistencies in your understanding within your team sooner, helping avoid that letdown when you put in place a feature you think is really cool, and the stakeholder says, well, that's interesting, but that's not what I need. That's not what I asked for. I asked for something, something different. That's a feeling where you put all this time into something and it turns out not to be the thing that's needed. I'd like to provide you with some tools to help lessen the risk of requirements changes that your stakeholder says, I actually forgot to tell you I really need this on top of that, and making sure your system hasn't missed big issues when you're designing on the basis of it. So why are requirements so important? Well, they're the number one, number two reason for runaway projects that go way over budget and over time. As I said, to deliver it successfully, you need to know something about what customers want. And fixing things in requirements phase is far cheaper. I put up a graph of this before, and basically I argued that over time in a project, as later phases of a project come in, the cost of fixing errors goes up. And a lot of it has to do with the rework involved. The fact that if we fix it in requirements, we don't have to, in the requirements phase, when eliciting the understanding, we don't have to throw away code. We don't have to throw away design. We don't have to throw away tests. But if we only find something late in the game, we might have to throw away all of those tests. Certain amount of documentation, certain amount of code, certain amount of design that went behind that code, the plans for the class diagram or what have you. And you got to throw a lot of stuff away if later it's found. So there's this kind of, as time goes on here, you can put it at time or project phase, there's this more or less exponential graph that goes on in terms of the cost to fix. Cost, to fix a problem. And this is one of the reasons that, of course, we iterate. We get something in front of the client soon, so if there is an error, they can spot it. You seek their input often, and you seek it early, right? To head off these problems. Okay. Interestingly, good requirements really can focus and simplify work. So they've done experiments looking at how much effort does it take to do a project from the first time where you're eliciting an understanding from the customer on the one hand. Maybe Donna, you're trying to understand what do they need? What does the customer need? Trying to get that information and implement it versus a situation where from scratch a team is given the exact specifications of what's needed. Exact specifications of what's called for. And they're given that and they're saying, go implement it. And the difference is huge. I mean, it's almost beyond imagining, but the recorded difference is that if you have the full requirements all specified out, all very, very clearly indicated, the costs can be like 1/100th of the cost of actually eliciting. I know it's hard to believe, but it's well above even a factor of 10, which is kind of striking. I mean, what this suggests is that elicitation of requirements, it really can put a drag on it. The lack of clarity in your mind about what's needed can mean a lot of rework, etc. So it's a big gap. Requirements are things that, if they're really clear, can really speed things up. And from a systems perspective, we like to talk about with software development an iron triangle. Has anyone heard of the iron triangle before? sounds like a medieval torture device, perhaps, but it's not. It's also not, the little triangle they play in an orchestra or something. Okay, I like an isosceles triangle. Let's try to do something like that. Okay, the iron triangle basically posits that software projects are trying to address three basic types of constraints. And there's little bits of difference how people phrase it. What's one of the constraints that software projects face? Or one of the things they have to worry about? Time. Yeah, there's time. That's a huge one. How quickly are you going to be able to do it? For this class, that's huge. Right? It's a stiff deadline. It's time boxed. You do it by that time. Nothing else after the end of the semester is going to matter for purposes of the course marks. Okay, so time is one. What's another one? And for real world projects, not for your project.
Resources?
Cost. Okay, good. And the third? I'll put value delivered. Okay, value. This is you could say quality. Sometimes people say. Some people will talk about scope. The sort of boundary of the project, what features you're delivering. You could say value, value delivered, which kind of combines both of these. You get about a bigger scope with less quality, or a smaller scope with a lot of quality. And the idea here is that it's actually pretty easy. It's extremely easy to meet one of these, and not if you don't have to worry about the others. Given enough time, with very low budget, and almost no value that I have to deliver, I can give you something, right? Even two is not that hard often. I can stay within budget and in dollar constraints if I can constrain the scope. If I can constrain the quality, if I don't have to worry about it being buggy. If you want really good quality and you're willing to pay for it, I can do that, but time might require a long time. So the basic idea is any two, not so hard. Getting within all three, really difficult. That's the iron part of the iron triangle. It's hard to fit your project into it, to squeeze it in, because getting it within all three of these constraints puts in place such pressures that it's easy to make it infeasible. And what you see here at the center part of this diagram, which is incidentally a causal loop diagram for those who've been in 394, just in or 394, it's in a different language, a slightly different language. So for those who are in 394, these arrows here are associated with opposite connections. So it's minus, and these ones are plus. But here we see requirements, process, quality, broadly speaking, affect several things of great importance to a project. These are kind of the aspects of the iron triangle. Quality on the top there, economy on the right, the dollars, delivery speed on the left, phrased a little bit differently. But what you'll see is requirements affect all of them. The degree to which the customers that are attracted to you, you're delivering value for them. Sometimes if you have a fixed product and you're bringing people in to buy it from the market, getting the right requirements ahead of time means you're attracting the customers who are good matches. In other cases, you build it custom for a client and you're trying to match that specific customer's need. But that ends up impacting product quality. Quality affects development effectiveness. If you're reworking the code base because you misunderstood a requirement, there's going to be issues with that. And it helps you, by the same token, engage in early faults elimination. Here, in terms of development effectiveness, you're putting out things that will enhance quality. Maintenance effectiveness, your ability to sort of refine the system over time in accordance with needs, contributes to product quality. And here's non-redundant development, which again has to do with throwing things out. So in short, this benefits the iron triangle. I mean, it hits all sides. Development economy, if you're throwing things out, you're not being too efficient. Speed takes longer to iterate to something of decent value. Okay, so requirements affect all these things. Requirements at some level affect all of the iron triangle. You're making the iron triangle more constricting, more difficult to map, to fit within, if you're not paying attention to your requirements, or if you're not really careful about them. So there's lots of benefits of good requirements. Actual faults are caught earlier, reduction in risk of the project, less chance. So I remember one project that I was called in as a consultant on. It was a large project, worked over many years for a large firm, and that project ended up getting canceled at the end because it just wasn't delivering the value. There was too much in the way of misunderstandings between the development team and the sponsoring organization. So, this is something which is a project risk. It lowers the risk of needless development, clearer expectations on the part of project, and more robust design. The design you build is appropriate for the actual requirements, not for just the requirements you thought were there but weren't, and therefore it can evolve more nimbly, etc. So what are some of the problems that come up in requirements when people try to express what's desired by the customer? Look, not every one of your teams is going to be able to go to the customer meetings. And you're going to hear requests at those customer meetings that you need to capture at some level. And I don't care whether it's in a formal requirements specification. I'd like to see that for my sake. Or I don't care if it's verbally to your team. But there needs to be an understanding of what the client is seeking for the next round. Or seeking for the next few rounds, right? What you're working towards. And what are some of the problems that can occur there? Ambiguity? You may say, well, come on, how ambiguous can it be? It can be really ambiguous when you're dealing with languages across disciplines. The specific words, in the health context mean a lot different things than they do to us often. We use them in a colloquial way, they use them in very specific ways, and that's just not obvious. They can be incomplete. This is a big one. This is a huge one, in fact. Look, often, people bring you an idea they've been nursing for a while, and they have some idea in their head. And they try to communicate it with you, but they forget certain aspects that are just, as I say, second nature to their field. Well, they assume, well, of course you know that. Of course it has to be password protected. We don't do anything in our organization that's not password protected. And they didn't communicate that with you. And that forces you to go back and rethink. So leaving things out is often as big, sometimes bigger an issue than problems and what's in there. Sometimes you have conflict in who's giving it. You have an organization, you have a couple different people, and they have different visions that are subtly different. You don't realize it at first, and you're getting conflicting requirements for these different sides. Similarly, some requirements may have been half-heard, others are really, really firm. Sometimes developers have goals, they would like to see this. They think this could be a cool feature, let's do that. And it ends up being really across purposes with what what's wanted by the stakeholders. Okay, another issue that's a really big one in dealing with requirements is the fact that a huge number of the requirements we deal with, a huge number of the things that we put in place, design, components, or code to deal with, are not given to us by the user directly. They're things the user is not aware of, but they're instead what I call derived requirements. They're things which are implied by what the user says, but they are not explicitly part of what the user wants. So maybe the user wants, I remember some years back, a project involving monitoring the survival of winter wheat. So they wanted to know basically when farmers plant winter wheat around a field, basically is it are they going to have to reseed in springtime? Did the winter wheat get killed, or is it still alive under the snow? And they want to be able to assess this so that they can plan their spring seeding, as soon as possible. They can plan their efforts in the crop fields early on. And the customer who might want that solution, they want the solution, but they're not thinking through necessarily all the implications of that. That, okay, if there's a system to monitor that, somehow that system has to live in the field in a power conserving way, a way that's sustainable power-wise. So, if it has to have some sort of sensor to sense this. The farmer may not care about sensors. They don't know anything about sensors. They just want to know, did the winter wheat survive? But okay, we need to image it. It needs to be something that lives in the field. It needs to be able to support itself energy-wise throughout the winter. So there needs to be a big battery associated with it. It needs to be able to survive very cold temperatures, which can often, deplete power, the ability for electronics to maintain their internal charges. And so you have all these requirements that come out of this in terms of the packaging of it that the farmer doesn't want. The farmer is not interested in those things, but they are needed to deliver. Similarly, for if you want to do something for mobile devices, there's only so many options you have for the technologies involved. There's only so many options you have in terms of how big that program can be in memory. And so as a technologist, we have to think about all these constraints, all these so-called derived requirements, which the end customer doesn't in the end care about. They don't understand what the big deal is. They want a solution which does this, but you're saying, well, wait, if you want it to do that, then it implies A, B, C, D, E, all these things, and all those things imply these other things. We can only get these sorts of devices. They need to be Android 6 and above, and they need to have this user configuration. They need to be in discoverable mode for Bluetooth. And for the customer, those aren't things they know about even, but they're implied by giving them their solution. So the idea here is that often what they want implies a lot of hows to you. They don't know what hows are going to be applied to you. You're the technologist, so you have to envision how it could be done, the different ways, and understand which of those you're going to embark on without them understanding the full implications of these things. But you're going to have to check, okay, we want to do it this way. That's going to imply these constraints and how it can be used. Is that acceptable? Think about derived requirements can be very important, and checking them sometimes with the customer, any implications. Okay, I wanted, because it will help you think through explicitly your requirements, might inform discussions with customers. I want to distinguish two types of requirements here. One type is what are called functional requirements, and I want to distinguish that from non-functional requirements, which sounds strange. So a functional requirement has to do with what features are in the system, what use cases it supports. What things does that allow you to do, through UI or through its interface or what have you. Often it's user-facing things. And here there's often a dialogue that needs to take place. This is a big gap. The customer knows the problem they want to solve, the gap between what currently is and what they'd like, and they want to narrow that gap. They want something that will help them accomplish something. But they don't have a good way of envisioning what the implications of that are, and you often don't really know what that gap is. You don't know where the pain is for them. And you know the technologies, but you don't really know what their needs are. So we're going to talk about this more in a minute. Non-functional requirements are going to be other things like the performance of the system, the reliability, the security of it, etc. Okay. So one of the big challenges here, this comes up just time and time again in my experience, is you're dealing with a stakeholder, and you think you can go to a stakeholder and say, tell me what you want. You can't. You can't go to the stakeholder and effectively get what they want by asking that. Because you could say they don't know what they want, and there's some truth to that. They can't envision a solution. They're not technologists. They don't sit and think about UIs all the time, these user interfaces which fill our lives. They haven't seen, 1/10 of what we have in terms of different types of user interface, in terms of the sort of supporting technologies. And when they look at that stuff, they don't parse it the way we do as technologists. So they don't distinguish between, oh, that's a modal window and that's not a modal window, or this one is docked and that one floats around. They don't really have those distinctions. And why should they? They're not trained in that area. And so they're not clearly envisioning a solution. They know there's this pain point. This hurts right now. It's painful. I can't do this certain thing. Can you help me? And that, along with that, is they don't know what the solution looks like. They're kind of looking for you to propose something that will allow them to solve it. At the same time, when they're describing it, they're using jargon often. Maybe it's property-related jargon, or jargon related to surgery, or jargon related to long-term care facilities, or patient service delivery interaction, where they're using this jargon, and they're not able to communicate, to unpack it enough to communicate it to you in lay terms. So they'll use terms and they'll talk about residents. Residents need to do this, or families need to do this. And you have to understand, okay, they're talking about people who live in the long-term care facility and families who visit there and maybe involve some in taking care of their loved one in the facility. And they may just refer to, residents, or they'll talk about, a certain process in that facility, and they know all sorts of detail about it, but you don't. So they don't always unpack their statements in ways that you can understand readily. So they're going to say some things, and sometimes you jump to conclusions which turn out to be off on this. They're not necessarily aware of what's feasible technology-wise. They don't know. Can you have an Android app and it just runs on iPhone? Or is that two different systems? Could it run on BlackBerry? Could it run on a regular smartphone? A regular phone. It's not a smartphone. I don't know these things. Maybe it's the same technology, maybe it's not. They don't know. They're not going to be able to envision the logical steps that must be taken to the solution. Divide it up, it has to go through this step and that step. It's just not their training. And they don't understand the technology implications of the step. Android 6 has this feature which Android 5 devices didn't have, and therefore you're not going to be able to support devices that are pre-Android 6 or what have you. Now, meanwhile, it's not just limitations of our clients. You folks on the technical team, me, when I go meet, we can't clearly immediately understand the domain-specific need. Maybe some of you have spent time in long-term care facilities and you'll start to understand some features. Maybe some of you have family members who are surgeons or people who work in real estate, and you'll have some understanding through that. But often, we don't really understand what the need is. What's the difference between MLS and other providers of real estate information or what have you? We don't really fully appreciate the gap between what is now and what is sought. We don't really know what other solutions are out there. Even us, we can't envision the solution really clearly. Generally speaking, we can't envision it really clearly up front. We have to see something concrete. They have to see something concrete. Generally speaking, until we see something concrete, and I mean us too, as technologists, it's hard for us to get our head around how it has to be different. And this is, again, why incremental development is so important. You get something in front of them, something in front of yourself, and it helps you break out of the box of your fuzziness in thinking about it. And we can't readily parse often their domain language, how they're saying things. So this is a big gap. It's a big gap, and you got to watch it, because one of the most dangerous things we do, we go and talk, and maybe because we don't want to ask questions, because we feel silly, ask about terms they're using all the time, or maybe it's because we think we know enough in the area. We come to conclusions, and those conclusions are off. They use a term like case, and we think we know what a case is, but it turns out to be off base. Okay, so for functional requirements, we're dealing with statements like this. The patron shall be able to reorder any meals he had ordered within the previous 6 months, provided all food items in that order are available in the menu for the meal date. This is kind of a statement of a feature. And you'll notice the way it's phrased. This is very general. This is not going into there's a dialog box and they should, press the button to order it after using, with up and down arrows indicate the quantity of items and pick from a drop down the particular item. This is very general. They shall be able to reorder any meal ordered within the past 6 months, provided all the food items on that order are available in the menu for the meal date. It's sort of a general statement about what the functionality is. So here it's talking about some user, some result. They shall be able to do something. Some object they'd be able to order a meal. It's often a qualifier here, provided that all food items. And these are often used to give these sort of statements. I'm not going to be particular. You don't have to worry about specifying all your requirements in this way. Just be aware this is best practice for a lot of requirements documents to unpack it in this way. And when you can use it, do. It's great. It will help you be a little bit specific about things. Be very clear about it. Okay, is this the patient or their family member here, or we talk about the administrator who needs to know about these things that were submitted by patients and families? Who's the user? What are they trying to do? So this user perspective way of phrasing it is useful. So I give you some example requirements here. Right? All network transmitted data includes health information shall be encrypted using 128-bit RSA encryption. Quite specific in terms of the requirements associated with that. Until the camera app is either closed by the user or experiences a timeout due to inactivity, the take photo button on the main IFE screen shall remain disabled. So it's giving a sort of characteristic of the system. This is lower level than the one in the last because it's referring to particular things on screens and so on. But the flavor is, again, this shall be the case. The system shall ensure that this following thing is the case. And here are some from a variety of books. This book by Birkin is on effective software management. Uyghur's Software Requirements book and More About Software Requirements are great books in these areas. And there's lots of examples of both. Give some more examples here. Use cases, did you folks take a look at use cases in 370? Okay, so that's part of your experience. They tell sort of a story about, okay, what's going on, who are the actors, how do they interact, and often these are specified before the functional requirements. So a great thing for your teams would be to give me some use cases that you're seeking to support for a given iteration. ID 2. ID 1, for a fair number of you, it might actually be you do spike prototypes, throwaway prototypes that will help your team understand the technologies, how they're going to work together, eliminate risks that they won't be able to work together, figure out how do we do these things best. Give me some spike prototype code. Yes, it's not part of the final code base, but it offers some functionality that you've accomplished. ID2, I'd start to see some real code, but in order to think through that code, you're probably specifying use cases. Use cases that say, okay, this is the type of situation that we're supporting. And these can be understood by many users, which is really good. You could take them to your stakeholder and say, have we captured it right? Yeah.
I've never really understood business rules in terms
I could. It won't be part of this lecture, but I could talk about that some. Yeah, there's a whole, it's an interesting sort of sub-area of software development. In fact, there's folks who work a lot with structured statement of business rules using what's called business process modeling language, and sort of talking about the workflows and the rules associated with work. And there's some elements of that to some of what you're talking about for your projects, in the sense of, let's take the case of this long-term care facility app, where you're dealing where patients or family members are submitting a picture or a description of an incident or a concern. Incident, I've listened to what the stakeholders using to say incident. Incident means something, but in any case, they're submitting this report, okay? If we think about how that's submitted, there's a set of rules for how that's handled when it's received by the folks who are using the results of the system. So it's not just being sent off into a black hole. It's being sent to administrators who need to respond to it. And that response process may be structured. And I'm not going to say that it has to be. I mean, in imposing a structure for my comments. So don't take this as imposing requirements. But it could be that, it needs to be passed in front of one of the two following managing members of management in order to vet whether or not it is to be triaged or thrown away or handled. And then, having been handled, it gets assigned to go to another member of the team for follow-up. And upon follow-up, it needs to notify the user who submitted it, this is being acted upon. And then, when following up, the person needs to follow it up within 7 days within the facility to meet this certain business goal. And having done that, they'll mark its status as resolved, or found to be no longer a problem because it's been cleared up, or that it's was not found to be an issue in the first place. So they'll mark that. And there's some rules governing this workflow, governing how things are processed, who's allowed to process them. And a lot of these business rules have to do with those sort of interactions. I'll see if I can comment on it in a later presentation. Okay, I do want to get through a few things here. Okay, so use cases are good things to give to me. They're good things to show to users. Let's talk about non-functional requirements. Use cases are talking about functional requirements typically. Non-functional requirements include a lot of things that are not part of features. These are some of them. The performance of the system, how quickly it operates, the footprint of the system. What do I mean by footprint here? Memory, particularly. Other resources. There's only, as I understand it, I may get this wrong, I think on Android there are 4 Bluetooth ports that can be opened, something like that at any one time. And if a given app occupies all of them, that's a big footprint because another app cannot access them, cannot use them. So memory is a big one, disk space, etc. Platform limitations that can only run under certain contexts when it's online, for example. Your system has to be connected to a network. Reliability, availability, so how reliable is it? How often can it fail and still be viewed as acceptable? Availability, is it 99.9% of the time it has to be up? How portable is it? Do you have to be able to move this to different devices, like from Android to iPhone to BlackBerry or Windows Phone or what have you? Security aspects, how really tied down in terms of the security of the system is this? Does it need to guard against intrusion by people on the device? Does it need to guard against intrusion in terms of eavesdropping on the data being sent back? So there's some security components here, reusability. To what degree are you hoping to reuse this code for other projects? Scalability, how many users can it handle? Should this thing be able to handle, 1,000 users at a time, 10,000? How if they have this on long-term care facilities all across Canada? Should it be able to scale to that size? In terms of searches in the database, in terms of processing the things coming in, and the usability of the system. Does it need to be usable by someone who's blind? Does it need to be something which is accessible to someone who has impaired motion in their hands? A lot of older individuals have arthritic hands, and do they have to be able to interact with the system? And so it requires another level of sort of thinking. So for performance requirements, some systems are specified down to level of what are called real-time guarantees. That this response has to be generated within 100 milliseconds or what have you, or connection needs to take place within a certain amount of time. And that can impose some quite complicated reasoning on the technical side to achieve that. Throughput, how many of these things can be handled per day by the system? The response time for performing an algorithm. So a search functionality for a certain type of complaint, or maybe with the VR system, it needs to operate with a certain frame rate. So I'm told by my colleagues more closer to the graphics area that virtual reality systems, such as were proposed by Raj in his presentation for this immersive reality environment online, or for the surgery case, I believe. Those sort of systems can be extremely powerful for enhancing your ability to visualize the situation, but they are subject to risks. And the risks, as I understand it, have a lot to do with performance. And the risk can be very severe, particularly in a surgical context. So the risk can include inducing vomiting, when you don't want your surgeon while you cut you open to be in that sort of situation, right? Where the VR solution is inducing nausea on the part of the surgical team. It needs to be a very sterile environment. It needs to be a safe environment where they're not feeling even lightheaded, etc. And with these VR goggles, I understand one of the big constraints associated with them is frame rate that can be associated with this sort of feeling of nausea. Okay, so performance sometimes is key to user satisfaction and, in fact, outright usability, whether it's feasible at all in that sort of theater. I understand also there's some users are more susceptible to this phenomena than others. I have a close colleague that I saw yesterday who was in the government of Saskatchewan, and he claimed smartboards. Smartboards, the earlier versions would make him feel nauseous, and so he couldn't use earlier versions. Now newer versions can. And this was a known issue, I guess, with certain types of individuals with certain visual problems would react adversely. So performance is sometimes very important for user experience. Okay, so let's get to some very concrete tips here. Okay, one of the most important tips is to repeat the understanding of a requirement to the stakeholder. So if you're in a meeting with a stakeholder, you're hearing certain things from them. Repeat them back to them, not in the same words. Try to rephrase them. Try to paraphrase, take it down, and then maybe 10 minutes later, 20 minutes later, whenever it's appropriate time, maybe towards the end of the meeting, you say, I'd like to summarize our understanding of this. Is this correct? It's one of the best ways you can do it, because you may have captured it in your own words, in your jargon. You think you've translated it from their jargon to yours, and you end up repeating it, trying to express it, and they say, wait a minute, you missed this important point. That's why I use that certain word, this. So try to repeat back understanding. to them. And I have a later slide here on that, which was more focused on written documents. But you may ask them for a restating of the thing. You may ask them to repeat it in different words, just to be sure that you've caught it right as well. So repeating it back from your side, though, is one of the best ways. A second thing that I'm surprised isn't in here, it should be, have more than one person go. You're really at risk if you have only one person going. You want several people. Why? Yeah.
Because you might miss out on something and somebody else might.
Yeah. You're going to be, your minds are going to be, your gears are probably going to be turning in terms of how am I going to implement this? What does this mean? What are the derived requirements? And that's not a bad thing that you're thinking about these things, because you may want to ask them, is it acceptable that, so maybe they want this system, they want this functionality to be able to, to report an immediate issue, and you say, okay, you're thinking, okay, that means they need to be connected all the time, and for them to be connected all the time means they either need to be on Wi-Fi, or we need to be going over their cell connection. And going over the cell connection may impose a charge. And you're thinking about all the stuff with Wi-Fi and cell networks and the way of transmitting information back to the server, and meanwhile they're going on and talking. And so you want at least a couple people there listening who be capturing these later things, but also they may understand it differently. They have a different parsing of the words. So I often find when I'm with students or I'm with other colleagues that what I heard is not quite what they heard, and we end up looping back and saying, could you clarify that issue? I thought it was this, but I may have misheard it. And often that identifies real misunderstandings early on. So repeat it on your side, ask the stakeholder to repeat it. Requirements docs should not be things just given to me and let stagnate. They should be living documents. They should be updated over time. They're useful things. They're useful things to know why are we building these features? What purpose are they for? Maybe you find that, after a lot of discussion, this requirement that was anticipated gets cut. Gets cut because they say that's too complicated, will never fly, or they have some changed need. They realize, okay, the Susquehanna Health Region will never sign into that for surgery, so we'll nix that requirement I mentioned earlier. You want to know, what does that affect in your system? That's the notion of traceability. You want to know, okay, that requirement that got cut, what parts of the design were meant to support that? What parts of the implementation, if any, were meant to support that? Okay, so traceability is really important, because from requirements flow design, and flows reviews, tests, code. You got to be clear if there's a ripple through effect from requirements, or else you may leave code in place that's not needed. So prioritize them. Talk with the stakeholder. Which of these is most important? Won't be clean. You may ask them, and they may give you an order in which is most important. Why might you differ from the ordering in the order you implement them? Give me a couple reasons. You actually alluded to it the other day. Yeah.
Some features may have dependencies on other features.
Yeah, exactly. Look, we can't really do this one until we've done these two previous ones. And to do those, we have to do this other one. It may not be a high priority for them, but it's a high priority for you to get it implemented. You can't do the others otherwise. What's another reason you may differ? By the way, that's a derived requirement. This has to come before that. What's another reason you might differ from it? Risk. I mean, each of them is associated with a different risk. You really want to sort of figure out, can you do this with, Node.js technology, or Angular? Do you in fact have sufficient offline support in the Google Real-Time API to put this into place, or do you need constant connectivity? You're not sure, and so this later requirement is going to have an impact on what technology you use. Do you want to get the collaboration through Firebase backend system or through Google Real-Time API? So you end up probing one of those requirements early on. It's not one that they prioritize really highly, but it's important for you to collapse your uncertainty. Prioritization of requirements is important. Another reason, quite trivial, but we do it all the time. That one's super easy to do. It's only the 6th one down on the list. But if I do the first, I could do number 6, number 7, number 8, like that. Takes almost no time. So why not throw those in there in the first round? And the client may say, fine, that's great. I didn't know you could do that so easy. I thought number 7 and 8 might each take a couple weeks to do. But we as technologists see what the dependencies are. We see what kind of go together, or what's easy, what's hard, and the client's not going to see that. Structure some acceptance tests around requirements. So if you have a set of tests, in some industries this is really big. I remember working in the pharmaceutical IT space, and this was huge. Acceptance tests for a system were giant. There's a sub-industry of people whose job it was to do acceptance tests on software for pharmaceuticals. And so it is a lot in certain health spheres, because the software is viewed as so critical that it has to work properly, that there are people who run validation suites on this stuff. But the idea here is very simple. You have a requirement, and you test that requirement in a system test. Let's test across the entire system through the UI, and that's part of the acceptance test. It says, yes, we can do this. Yes, we can sort in this way, or we can find things, or what have you, as part of the test. And you can say to the user, the stakeholder, this has been verified, as part of our acceptance. Think about the requirements that are left out. What is missing now? What are they operating with an assumption about? You will find, again, domain side people are not technologists. They will make all sorts of outlandish assumptions sometimes. They will assume that you can communicate back from a phone at any time. They will assume perhaps that the software that runs here can run on any other smartphone platform. They may assume that any app can call up to any other app very easily, or can exchange data with it. And these things aren't the case, but they don't know that. And so trying to find out if they're assuming some of these things is useful. Asking a stakeholder, what is the problem? Like, what problem are you trying to solve is often really quite useful. The system is designed to solve a problem. It's designed to deal with a gap. And having them state that is really often useful for you to sort of focus your understanding of what the overall goals are. Some words can be ambiguous, culturally geographic, or geographically specific references, certain words that are specific, things that have unclear magnitude. You can be quite specific. If you say fast, what does that mean? The search functionality should be fast. Okay, so a search should be able to complete within 5 seconds, 30 seconds, within less than a second. Might, may, could, should. You can instead say shall or must. Okay. Final thing here, user requirements change process. So when a user comes and has a change to an existing requirement, you can go back and there should be a process by which it has to go through some workflow. And that workflow should flow, most importantly, through whom in the team. A requirement change request should go through whom? Project manager. It's the project manager's responsibility to help broker that. In real life teams, and teams out there in industry, project managers often serve as the point person between the client and the technical team. They're the one who is envisioning future rounds of deliverables. They're the one who knows how much in the real world the client paid for it, on what terms you did this. They're the one who knows the other competing projects this team could be assigned to once this is done. And they're the ones who can decide, how important is it to deliver on this for the client under the existing contract? To what degree should there be a new contract put into place? To what degree should we just say to the client, sorry, we're not able to deliver on that for this product round. We'll have to look at it down the road. We need to move on to a separate project that's been assigned to us. It's the project manager who has the maturity to do this, typically. They have the global knowledge. The individual team members, the developers, it's bad news if the client can call you directly or can contact you, because they will prod you and say, add this feature for me, I really need it, I need it by tomorrow, and it gets really unpleasant, and you don't know how much they should be paying for it, whether they already got a steal on the contract. You don't know that. Okay, so let's talk a little bit about these documents and tests. So requirements traditionally inform acceptance tests. These high-level system tests that ask, is the system ready for use? And it might occur at each deliverable. High-level design often go into system tests, detailed design into integration tests, coding into unit tests. This stuff, developer stuff. Unit tests typically done by developers. Integration tests, some by developers, but often by the test team as well. Some mocking required there because you have inter-component dependencies. These upper ones, test team's requirements, and a lot of this is test team traditionally. Okay, so missed error here, missed ambiguities, missing requirement. It's been forgotten. It can either mean the user doesn't care about it, or cares about it so strongly that it's just so second nature they don't even think to mention it. There's a big difference between these two. Here they're counting on it. Of course you're going to do that. Here, it's not really part of their desires. Often it means the users forget to even think about it. It's so part of their training that they're not even mentioning it. Another common source of error is observational error. You misheard the statement. You misinterpreted it. Or you misrecalled it. You only wrote it down later and you forgot what they said and you wrote down something that's a little bit different. Even if it's the next day, you forget what was said. So you might record the conversation, at the least have several people there. Maybe use Google Docs and type notes in a structured way into the doc simultaneously, so you can be capturing, refinements of your thinking in the same document rather than, 4 different documents for each person there, each technical team member. But see if you can write it down live or very, very soon, and see if you can get multiple people hearing it and see if you can get them to restate it. Or better yet, you restate it and you hear what they say. Not easy. And look, if you can catch 2 problems, it'll mean it'll mean a client who's where there's been you've avoided a failed expectation twice, which is good. Another thing is you completely forget tacit requirements for entire areas. You put on too much of the user hat and you forget all the technical requirements associated with it. The performance, the operability, the scalability, the maintainability, security. You forget, this has got to run on real devices that are currently on the market and what's out there and what's feasible. Got to be thinking about all these implications that are implied by those user statements. And those things are easy to put aside when you're with the user because they're not mentioning them. But they're huge. They're huge because you've got to navigate that. You've got to navigate those complexities. And maybe the user really, really wants something, but it just can't be so using traditional technologies. I remember a case in the past year. We had a client who really, really wanted the ability to live on this app that we had. It was a market-leading app that we had provided commercially. They really, really wanted to be able to use it to record audio. No problem, it does that. But they wanted to be able to parse that audio in real time using speech to text and have that text understood so it could prompt other questions if they were saying certain things. This is just not going to happen with today's technology, given different accents, given the fact you have to do it live on a mobile device with limited power, and you've got to be running these audio processing and text recognition algorithms. Text recognition algorithms these days, even for really clear, well-articulated English under great recording conditions, maybe get 50% of the words right, and we're trying to recognize maybe 75% under perfect recording conditions. And you're trying to do this to the person, their smartphone, in any environment with cars roaring in the background, wind whistling, and then use that real time to trigger another question. It's just not going to happen. It's not going to happen. So, we have to tell them this is just not viable. And that's part of our role as technologists to say, look, this is not a viable thing. We can look into it down the road. We can do tests with it. We can evaluate libraries for this, but promising it is just too risky. So, tacit requirements, the implied requirements, are often very important. The derived ones. Also, things like this, scalability. Just keeping in mind, do they need this to scale to 100,000 people, or just to 100 at a time? What is the security side? In terms of privacy and guarantees there, in terms of performance, these things are often left out. Right. So there's a whole sub area of requirements having to do with change requirements, change requests. So here, you gather some requests and you try to clarify, you negotiate what the actual requirements are, what it will look like. One of the best ways to do this is to create a wireframe sketch. Is that a familiar thing? Good folks? No? Do a sketch. I mean, literally a sketch sometimes. It can be done in, with tools, with graphics tools, but you could literally draw it out on a piece of paper and show this is what the buttons might look like. And when you press this one, it'll go to this screen. And you draw out the screens. You draw them out in a way that's on a piece of paper, and you show it to the user. And you say, this is what we have in mind. Or maybe you do a PowerPoint presentation. You say, when you push this button, you go to slide 20. Here, this is what you see. And you draw it out with rectangles and stuff like that. You do it in Visio and have slightly nicer sort of renditions. But the point is, when you're negotiating the requirements, when you're talking with them, when you're giving them a vision, you show them something concrete. You show them put something in front of them, even if it's just a sketch on a blackboard. It goes a long way. It goes a long way. They may say, oh, that's too many buttons on a page. They may say, well, wait, this has to be viewed on small phones. Probably that's not going to come from them. That's going to come from you. Android phones vary hugely in size. iPhones are more standardized. You might be aware of that and say, put the brakes on there. But the point is, they'll give feedback that will clue you in. And basically, the customer is going to decide what combination of requirements and price and time are acceptable to them. Okay, I don't have time to go through this. I'll give you a lot of additional specifics here. Basic deal is requirements in industry projects. Often we divide requirements up into a set of documents, okay? So there's product requests, marketing requirements document, vision and scope, system requirement specification. These become increasingly sophisticated, and the SRS, commonly called the SRS, is used then to drive the technical work. These ones are more visioning for what this could look like before it pins down that we're definitely doing this. And you know, we've really drilled down to the level of specific requirements. Okay, and I give some examples here. The Birkin book, which I have a couple copies of, I think, in my office, has quite a bit of that. Don't be afraid to ask for definitions of keywords that they use quite a bit, and you may want to emphasize these. Okay. I think that's all for requirements. Perhaps a dull topic, but you'll find how hard it is. You'll find how hard it is with real requirements. It's not easy, and it may be hard in ways you're not noticing. That's the risk. You may not notice that you've taken something down that is not what they meant. So try to apply some of these terms, particularly asking for them to listen as you repeat back key requirements. Okay? Thanks very much, and we will continue on Tuesday with additional topics. On Tuesday, I'm going to be talking about something on the contract side and specifications which you need to adhere to. Okay? Thanks very much.